Another dimension of stormwater retention is gravel-filled swales, and in fact swales in general. The next few slides talk about swales and their effect on stormwater retention. In this instance, we're talking about gravel-filled swales, where in a parking lot context, we have islands in between the parking bays that are filled with gravel, and water flows across the impermeable surface directly into these gravel trenches, these gravel swales, and the condition in this landscape is similar to the diagram that I showed you earlier, where water infiltrates down through the gravel into the adjacent landscape. We see here another example where adjacent to a parking lot we have curb cuts that allow runoff from the parking lot to enter a gravel-filled basin. And the water percolates down through that gravel basin into gravel understorage and allows more water to infiltrate into the landscape, reducing the volume and rate of flow of runoff across the surface. Here we see an example of open swale systems where instead of putting the water into a pipe and piping the water from one location to another, we're using an above-ground swale system that moves the water from one location to another. And periodically, we may have what's called a check dam. We see in the lower right-hand diagram where I'm pointing with the cursor, a small check dam that backs water up in this channel, promoting infiltration of water and thereby reducing the volume of runoff that has to be dealt with. And so the use of open swales systems is a way of promoting infiltration of runoff from impermeable surfaces, such you see in the parking lot on the upper left, into the surrounding landscape. Bioswales is the same idea, except we are planting the swale with plant material. The landscape underneath of the swale, again, has some kind of drainage property to it, high drainage property with gravel understorage. But the plant material helps to slow down the velocity of water, and it helps to evapotranspire moisture from the ground back into the atmosphere. So this evapotranspiration promotes a reduction in the amount of runoff volume that has to be dealt with. The gradual infiltration of this water reduces the volume of runoff that has to be dealt with. So these bioswales are quite popular as a means of capturing water from impervious surfaces and infiltrating it into adjacent landscapes. And the plants then help to purify the water and transpire the moisture back into the atmosphere. We see some examples of bioswales here. In the upper left, we see a series of catchment basins that are created by check dams that are catching water coming down through the swale system, gradually moving it from one portion of the swale into another portion, retaining the water so that it will hopefully infiltrate into the porous surface created by the plant material. In the lower left-hand diagram, we see adjacent to a parking area, a swale area that's been planted with various types of vegetation so water sheets off of the adjacent roadway and the parking lot into the bioswale, infiltrates into the bioswale, into lower gravel structure, and the evapotranspiration of the moisture back into the atmosphere again helps to reduce the volume of runoff. Reducing volume of runoff is absolutely critical. Here we see some examples, other parking lot details where again we have an open swale system that's filled with gravel, So the open swale, gravel-filled swale captures water coming off of the parking lot and infiltrates it. We see examples here where there's a bioswale that contains gravel. Here a gravel-filled bioswale that is helping to capture water coming off of the parking surfaces and infiltrating that water into the landscape rather than having it run off. So again, reducing the rate of discharge, reducing the volume of discharge, and by promoting infiltration and biofiltration, improving the water quality. Two more examples of bioswales in a very close quarter landscape in the lower right here, where we're in a walking situation between parking lot and building, yet there's enough space here to capture runoff coming off of the parking lot and infiltrate that runoff into the landscape. Another example of bioswale here where the water is sheeting off of the parking lots into the bioswale. That same principle is illustrated in the diagrams on the left. On the lower left, we can see a situation where we're capturing water coming off of a public street and infiltrating that water in a rain garden immediately adjacent to a curb cut inlet that brings water from the street into the rain garden itself. Here we can see in the upper right, street water captured, brought into a rain garden and infiltrated. We can see a bioswale in between two buildings that is being used to infiltrate runoff from an adjacent parking lot, and we see another example of a bioswale here.